Hello everyone! In this lesson, we will continue to study the basic knowledge module. Today, we are going to learn the 10th lecture, causal system and non-causal system, stable system and unstable system, and the basic methods of system analysis. First, let's look at the definition of causal and non-causal system. Causal system refers to, in the zero state, a system that will produce output response if and only if there is an input signal to stimulate the system. In other words, the output of a causal system must appear after the input signal stimulates the system. This characteristic of the system is called causality. Therefore, a system with causality is called a causal system or non-advanced system. Otherwise, it is called a non-causal system. Well, what is the judgment methods of causal system? It's very simple. If the output of the system does not lead ahead of the input, such a system is a causal system. Let's take a look at an example. Does equation yt equals ft plus ft minus 2 represent a causal system? When t is equal to 0, y0 equals f0 plus f minus 2. By analyzing this expression, we can find that the response equals the current stimulus plus the previous stimulus. So, this system is a causal system. Next question. Does equation yt equals ft plus ft plus 2 represent a causal system? When t is equal to 0, y0 equals f0 plus f plus 2. In this expression, the current response is equal to the current stimulus plus future stimulus. So, the system is a non-causal system. In physics, the achievable systems are all causal systems. The concept and characteristics of a non-causal system also have certain practical significance. For example, in voice signal processing system, signal compression and expansion are very common. Here, the signal compression is fast-forward that you have used before, and signal expansion is slow down of the signal. Of course, if the independent variable of the signal is not time, but displacement, distance, and brightness, then in the physical systems taking these as variables, causality makes no sense. Well, what is causal signal? The signal that is connected to the system at t equals 0 is often called a causal signal. As mentioned before, causal signal can be described by step signal. Ft equals Ft times delta t. Obviously, t is less than 0. Ft is equal to 0. Therefore, it is a causal signal. Let's look at another example. In zero-state response, yzst equals f2t is a non-causal system. Why? Let's analyze. If t is less than t0, ft is equal to 0, then yzst is equal to f2t is equal to 0. According to what we learned before, it happened when t is less than t0 over 2. That is to say, when t is greater than t0 over 2 and less than t0. In this interval, yzst is not equal to 0, but ft is equal to 0. It can be found that the zero-state response of the system appears before stimulus ft, so the system is a non-causal system. That's the content about causal and non-causal systems. Next, let's look at stable system. If the stimulation or input of a system is bounded, the zero-state response of the system is also bounded. Then the system is said to be bounded input, bounded output stable, referred to as BIBO stable. Sometimes it is said that the system is zero-state stable. Otherwise, a small stimulus such as an interfering signal may diverge the system's response. The stability of a system can also be explained in this way. If the absolute value of the system's input f is less than infinity, the absolute value of its zero-state response y is also less than infinity. Then the system is said to be stable, otherwise it is unstable. More detailed content about system stability will be discussed in the following sections. Next, let's discuss the basic methods of system analysis. System analysis methods include time domain analysis and transform domain analysis. The main contents include the establishment of system model and the solution of mathematical model. There are two ways to build a system model: input and output description method and state variable analysis method. Input and output description method focuses on the relationship between stimulus and response, regardless of the internal variables of the system. Normally, it is used to study single input and single output system, and it is to write unary nth order differential equations or difference equations. State variable analysis can not only give the response of a system, but also describe internal variables such as changes of capacitor, voltage, or inductor and current. Generally, it is used to study multiple input and a multiple output system, and it is mainly to write multiple first-order differential equations. You can use this method to do time domain analysis of a higher order system in circuit theory. The solution of mathematical model is mainly divided into time domain analysis and transform domain analysis. We normally use classical method to do time domain analysis. Continuous systems are solved by differential equation. The discrete system is solved by difference equation. When solving the zero-state response of a system, you can also use convolution integral or convolution sum. Transform domain analysis includes Fourier transform, Laplace transform, Z-transform, discrete Fourier transform, and discrete Walsh transform. In this course, we mainly discuss the Fourier transform, Laplace transform, and Z-transform. Other transforms will be discussed in the following course. Now, let's review the contents of the basic knowledge module. We mainly studied signal description and classification and typical signals. As for signal description, you should know the relationship between its mathematical expression and the corresponding waveform. We can classify signal according to extra use and according to the time characteristics. You should also note the concept of continuous time signals and discrete time signals. As for the calculation of signals, you should master their mathematical description and their engineering significance. Step signal and impulse signal are two special signals, and they are singular functions. You should master their definition, properties, and the relationship between them. As for the description of system, you should understand the relationship between mathematical model of a system and the block diagram of the system. Master the single adder method and the double adder method of block diagram of the second order system. In addition, the definition and properties of linear time invariant system are also the key points you should master. In particular, the basic concept of signal and linear system are also very important for the study of the following modules. I hope my class is helpful to your study. This class is over. Thank you. Goodbye.